let's just pretend like we did. Okay, so we have the substitution rule, which is kind of like the reverse chain rule. Don't judge my handwriting. I'm flying by the seat of my pants today. All right. Look at this antiderivative. The integral 3x squared times 4 plus x a third to the fourth power dx. That looks a little bit more challenging than the type of problems we've been looking at, doesn't it? But we want to be able to do it. We want to be able to do it well. What's different about it? That's the first one you got to recognize. Okay, very good. Dx, down dt. That it really isn't going to matter. But right now, if you wanted to evaluate this, you would have to multiply it 4 times out and then distribute the 3x squared. That's our option right now. Anybody in favor of doing that option? Okay, all right, that boy, you like to do is difficult. I like the way you roll. Okay, you start. Go ahead, start right now. We're gonna try it the other way. We'll see who wins. Okay, all right. He's such a liar. All right. So what I'm going to do is I'm going to substitute just like we would when we do the chain rule, and I'm going to make my substitution 4 plus x cubed. What I'm going to do is I'm going to take the derivative of that. The derivative of u is du. Do. U prime. Yeah. What's the derivative of 4? What's the derivative of x a third? Dx. Hey, wait a minute. Look at here. I could rewrite this integral. What do I put instead of the 4x plus or 4 plus x a third? No. What is that? That's u. What power? Instead of the 3x squared dx, what could I put in that place? Du. That looks like an easy antiderivative to go with. What's the antiderivative of u to the fourth? Plus c. What do we put back in place of the u? Done. You liar. Yeah. Okay. When we see this, okay, that means we take an antiderivative. The antiderivative. The antiderivative of x is x squared over 2, right? But it's also x squared over 2 plus 1. Because when you take the derivative of x squared over 2, you get x. When you take the derivative of this, you get x. And so instead of just writing the constants all the time, we write plus c, because this could be any constant. And will you use this someday? Yes. Super important in differential equations. Half point wrong on test every time. Yes. Let us be consistent. When we take the antiderivative of this, the integral and the dx go away, right? So when we take the integral of this, okay, the integral and the du go away. So the 3x squared was absorbed by the du. Think about what it means, folks. What does this thing even mean? It means if you take the derivative of it, you get that. Do you see if you use the chain rule, what's the derivative of the inside? 3x squared. There it is. Yeah. Yeah, very good. Let's put our phones away, guys. Not be addicts. Here we go. Let's do number 2. A little bit more challenging. Okay? What is u? What is du? Did anybody say 7x in their heads? Be honest. You don't just look at what's sitting there. You actually take the derivative of this. What's the derivative of 4x squared? 8x dx. I don't see an 8x there, though. I see a 7x. Maybe we could divide by 8 to get 1/8 du is equal to x dx. And then maybe we could multiply by 7. Okay. U is x squared minus 3. Everybody see that the derivative is 8x dx. I don't have an 8x dx. I have a 7x dx. How do I get rid of the 8 and get a 7 in? I divide by the 8. I multiply by the 7. Question. Because 3x squared was sitting right there. In this situation, I don't have this 7x dx. That's not 8x dx. I got to make them the same in order to substitute. So look at what I have now. I'm going to replace some things here, okay? I've got my integral, and I'll start kind of wiping them off so you can see. What goes in place of 4x squared minus 3? U. So that's gone. To what power? So now that cube is gone, I have to get rid of 7x dx. What goes in place of 7x dx? Yep, so I got a du, and I'll stick the 7/8 out front. It's just a constant multiplier. You can put it in front there or out front there. Doesn't matter. Now I can handle that. What's the answer of u cubed? U to the 4th over 4 times 7 over 8 plus a constant. What is u? So I've got 7 times 4x squared minus 3 to the 4th power over 32 plus a constant. That means if you take the derivative of this, you get that. Go get some brain food. Come back smarter. Today's an epic day. You are going to do awesome with it. I believe in you. All of you. Every single one. Okay, YouTube, we're right now, I just threw 2 problems up on the board. So Carter or anybody else watching this, students are trying these 2 problems. I've shown what U is. They're taking some time, checking with a partner on an answer, trying to verify that they could carry out this basic step, then we'll move on from there. Okay, excellent. All right, so you got those answers. Let's continue. That's level 1. Those are the most basic that I can find, guys, okay? Let's get a little bit more challenging, okay? All right, we look at this one. 3 looks a lot more challenging, doesn't it? We start with identifying u. What do you think u is? Square root of x. Now, for those of you who can really identify u because there's more challenging problems, what you want to ask yourself is this. What do I take the derivative of to come up with something that's challenging to get rid of? So, for example, I know the antiderivative of cosine. It's sine. But this square root of x in the denominator, it's bothering me. Okay? Well, here's the deal. What's the derivative of square root of x? 1 over 2 roots of x, right? So are you going to come up with a root of x in the denominator? Yeah, so that's why the square root of x is a good choice for you. So therefore, du, as you said, is 1 over 2 roots of x dx. That's the derivative of the square root of x, right? I have a square root of x in the denominator. That's nice. But I don't have a negative 2 in the numerator, and I don't have a 3 in the denominator. What would I multiply through by to get a negative 2 in the numerator? Negative 4. So negative 4 du is equal to negative 2 over the root of x dx. Everybody okay with that multiplying? Okay, I got my -2. Now I need to get 3. So I divide by 3. How you organize your work is up to you, but here's how I do it. I do the -4/3, and I always put the constant out front. And I have an integral. I put the du over here. And then I start to cross stuff off, okay? -4/3 du. What did that get rid of? -2, 3 roots of x, and the dx. Okay, so that got rid of that. All right. All right. Now, what takes the place of the root of x? Yep. So I'm going to put u. What's the only thing that remains? So I have the cosine of u. Now, some people are like, well, why don't you get rid of cosine? I don't have to. I know the antiderivative of cosine. I'm not trying to get rid of that. I like the antiderivative of cosine. What's the antiderivative of cosine? It's just sine. Of u. What's u? Root of x times -4/3 plus c. Piece of cake. Upside down. Reverse chain rule. Yep. How can I check my answer? Take the derivative, and you should get what you had up before. Okay. Next problem. I continue to forget to change this notes all the time. We're going to do 4 plus tangent of x. Tangent squared would be significantly more difficult. So we aren't ready for anything like that. Okay. Anybody want to say what u is? Good. 4 plus tangent. So du is secant squared of x dx. Good. Do I have a secant squared of x dx? Yeah. This one works out nice, doesn't it? I have the integral of what? U to the 3rd power du. What's the antiderivative of u to the 3rd? U to 4th over 4 plus a constant. Make sure you put u back in. So I got 4 plus tangent of x raised to the 4th power over 4 plus a constant. That's my answer. Du is secant squared of x dx. Yep. It's okay. Hey. Number 5 is a little bit tricky, but the rest are pretty clear cut. Okay? Yeah, exactly. Anybody want to guess what u is here? 1 minus x squared. What is du? -2x. I don't have a -2x dx. I have a 3x dx. How do I make a 3 there instead of -2? Divide by -2 and multiply by 3. So 3 over -2 du is equal to 3x dx. What do I put out front? Integral and du. Being I put the -3 over 2 du there, what do I get rid of? 3x and the dx. What goes in the place of 1 minus x squared? So 1 over u to the 1/2, right? Or u to the -1/2. What's the antiderivative of u to the -1/2? U to the 1/2 divided by 1/2. Divide by 1/2 the same as multiplying by 2. So what's going to happen? 2's cancel. One half. 6 looks difficult, doesn't it? It's no big deal. Gina says no. It's easy. I like the way you think, Gina. U is what? Good. What's du? Awesome. I don't have a 2x plus 1 dx. Multiply by 2. So 2 du is? Do you have a 4x plus 2 dx? You do. Now, just to show you how complicated this could get, folks, instead of a 4x plus 2, suppose it was a 4x plus 3. That's a lot trickier. That's a very messy integral to deal with. So finding antiderivatives is significantly more difficult than finding derivatives. Okay? It's just the way it is. So, integral. I put the 2 out front. Put the du. Get rid of the 4x and the dx, and the inside is u. So what do I got here? What's the antiderivative of u to the negative 3? U to the negative 2 over, so what will happen to the 2's? What am I left with in the numerator then? Negative 1. There's 2 left. These are fun ones. What should u be here? Should I choose u to be e to the x, or should I choose u to be e to the x plus 1? There's a reason to our madness. Watch. If I choose u to be e to the x, what's the derivative of e to the x? But that doesn't take care of the plus 1, does it? If I choose u to be e to the x plus 1, what's the derivative of e to the x plus 1? Oh, that takes care of it. So u is e to the x plus 1. Good choice. You guys are smart. Du is e to the x dx. Hey, e to the x and the dx are gone. So what's my integral? 1 over u. 1 over u. 1 over u. No, 1 over u. No, 1 over u. 1 over u. Stop it. Good time. Okay. What's the antiderivative of 1 over u? Look at that! Everybody for Jake. 1, 2, 3. Nice job. What'd you say, buddy? Yeah. Remember, what do you take the derivative of to get 1 over x? Take the derivative natural log, right? Antiderivative of 1 over u is natural log of u, or natural log of e to the x plus 1. Sweet. Nobody got it second hour. You're proud of you. Look at that. I get you off your cell phone, all of a sudden you just like answer stuff right and left. Okay, last one. Do you choose u to be sine, or do you choose u to be cosine? What's the derivative of sine? Cosine. What's the derivative of cosine? But it's not negative sine squared, is it? So we like u to be sine of x. What's du? Cosine of x. Hey, what am I missing? A 4. So 4 du is equal to 4 cosine of x dx. Well, it's u squared. Well, now that Aaliyah's okayed it, I guess we can move on. Right? She says, I suppose. that a word? Suppose. Okay, what do I have left? U squared. What's the antiderivative of U squared? U to the third over 3, so we have 4u to the third over 3 plus c. And what is u? That's the antiderivative, folks. Isn't that awesome? I have your worksheet. You have only 2 assignments left for this unit. We're going to test on Thursday. You will not get a new assignment tomorrow. Let me hand it to you before you walk off the